Welcome. Today we will be breaking down the production of thyroid hormone. Let's begin by labeling the blood vessel and follicular cell. In order to produce thyroid hormones, TSH is needed. TSH is a hormone that is produced in the pituitary gland and sent through the blood. Once TSH arrives at a follicular cell, it will bind to the TSH receptor. This causes ATP to convert into CAMP. Located on the basolateral membrane is a sodium-potassium ATPase pump. Next to the sodium-potassium ATPase pump is the NIS or sodium iodide symporter. The NIS brings 3 sodium molecules and 1 iodide molecule into the follicular cell. The iodide molecule will then travel through pendrin. The enzyme TPO found on the apical membrane will then oxidize iodide into iodine. Iodine then combines with tyrosine amino acid molecules located on the thyroglobulin molecule. This leads to the formation of MITs and DITS. 1 MIT and 1 DIT will combine and form T3, and 2 DITS will combine to form T4. T3 being the active version of thyroid hormone and T4 being the inactive version. The newly formed thyroid hormone is then taken into the cell through a receptor called megalin. The thyroglobulin complex is then contained in a vesicle. A lysosome will fuse with the vesicle and begin to break it down. The products of this breakdown include MIT and DIT, amino acids, and T3 and T4. Amino acids are then brought to the nucleus to be recycled. Intracellular deiodinase removes the iodine from the MITs and DITs and recycles it. On the basolateral membrane, a T3 and T4 transporter moves the newly synthesized thyroid hormones across the membrane into the blood vessel. Inactive T4 can be converted to active T3 by peripheral deiodinase when needed.